Imagine this. Somewhere out there in the vast expanse of the universe, there could be another Earth, a twin waiting to be discovered, a world not so unlike our own, where oceans shimmer under a golden sun, and perhaps life as we know it could exist. What if our search for life beyond Earth is closer to reality than we think? Tonight, we embark on a quiet yet exciting journey to explore the top 10 most Earth like exoplanets. Planets that might just be the homes of future civilizations or even mirror images of our own blue planet. Come, drift with me through the stars, and let's find out which of these distant worlds could one day share the same fate as ours. When we look up at the night sky, all those distant stars may seem like little more than pinpricks of light far beyond our reach. But what if I told you that each of these stars could be surrounded by planets, exoplanets, many of which might be strikingly similar to our own Earth? What if, scattered across the vastness of the universe, there are worlds that share the same conditions, the same potential for life, the same natural beauty we find here on our blue planet? To understand what makes a planet Earth-like, we need to first consider the criteria scientists use to define such a world. What exactly makes a planet capable of supporting life as we know it? Let's embark on a quiet journey through these defining characteristics as we learn what we're looking for when we search for our twin. Size matters. One of the first characteristics that makes a planet Earth-like is its size. The planet must be roughly similar in size to Earth, not too small and not too large. If a planet is too small, it may not have enough gravity to hold onto an atmosphere, which is essential for life. If it's too large, the planet may be a gas giant, like Jupiter, which wouldn't be able to support life as we know it. Earth's diameter is about 12,142 km, and its mass is roughly 5.97 or 1024 kg. The ideal Earth-like exoplanet would fall within a similar range, not much smaller or bigger than Earth, as this balance is crucial for maintaining stable conditions on the surface. Temperature, the sweet spot. Next, we look at the temperature of the planet. For life to thrive, a planet must fall within a certain range of temperatures, neither too hot nor too cold. Too hot, and any liquid water would boil away into vapor. Too cold, and water would freeze solid, leaving little chance for the complex chemistry required for life to occur. This temperature range is often referred to as the habitable zone or Goldilocks zone. It's the sweet spot around a star where conditions are just right. Not too close, not too far, for liquid water to exist on the planet's surface. Earth sits comfortably in this zone, orbiting our sun at a distance where the temperature is just right to sustain life. An exoplanet within this zone of its star is considered potentially Earth-like. However, simply being in the habitable zone is not enough. We must also consider other factors, such as the planet's atmosphere, its orbit, and its composition. Atmosphere, the protective shield. Another defining feature of Earth-like planets is the atmosphere. Earth's atmosphere is a complex mixture of gases, including nitrogen, oxygen, and traces of other elements like carbon dioxide and argon. It serves several important functions, including regulating temperature, shielding the surface from harmful radiation, and maintaining the right balance of gases to support life. An exoplanet's atmosphere must be dense enough to protect its surface from harmful radiation, but not so thick that it creates a runaway greenhouse effect like Venus. For an exoplanet to be Earth like, it should have a balanced atmosphere that can help maintain moderate temperatures and support the potential for liquid water. In addition, the composition of the atmosphere should allow for the presence of gases such as oxygen and carbon dioxide, which are vital for life processes like respiration and photosynthesis. Orbital characteristics. Stability is key. A planet's orbit plays a crucial role in determining its potential habitability. An exoplanet that orbits its star too quickly or too erratically might experience extreme temperature fluctuations, making it difficult for life to survive. On the other hand, a stable orbit within the habitable zone, like Earth's orbit around the Sun, allows for consistent conditions over long periods of time, which is essential for life to develop and evolve. In addition, the tilt of the planet's axis affects its climate stability. Earth's axial tilt of about 23.5 degrees is responsible for our seasons, helping to moderate the temperature and create diverse environments across the globe. A planet with a similar axial tilt might experience similar seasonal variations, which could contribute to a more balanced ecosystem. What's beneath the surface? While the right conditions on the surface are essential for life, the composition of the planet itself matters just as much. Earth's composition, its rocky surface, core, and magnetic field contributes to the stability of our environment. An Earth-like exoplanet would need a similar structure with a solid or rocky surface, a core capable of generating a magnetic field and geological processes that could help recycle essential materials such as carbon through the planet's crust and atmosphere. One of the key ingredients in the search for Earth-like exoplanets is the presence of water, particularly in its liquid form. Earth's oceans, lakes, rivers, and rainfall are essential for life. While a planet doesn't necessarily need oceans as vast as Earth's to be considered Earth-like, the presence of liquid water in any form is one of the most important indicators. Water is a universal solvent, playing a vital role in the chemical processes that sustain life. If we find an exoplanet with signs of liquid water, it significantly increases the chances that life could exist or could have existed on that world. The search for the perfect match. Finding an exoplanet that meets all of these criteria may seem like a daunting task, and in some ways, it is. But advances in technology and techniques have made this search more fruitful than ever before. Telescopes like Kepler-TESS, Transiting Exoplanet Survey Satellite, and future missions like the James Webb Space Telescope allow astronomers to peer deep into space, looking for planets that orbit stars much like our Sun. As scientists continue to discover more exoplanets, the definition of what makes a planet Earth-like is evolving. Some scientists suggest that life may exist in forms we can't even imagine, perhaps on planets with atmospheres vastly different from ours or with extreme temperatures. However, for now, when we speak of Earth-like exoplanets, we're focusing on those that bear striking similarities to our own planet, with the potential for life, water, and the right conditions to support it. In the end, the search for Earth-like exoplanets is not just about finding a planet that looks like Earth. It's about finding worlds where life, in some form, might be possible. Worlds where humanity's dreams of exploring the stars could one day become a reality. Imagine for a moment that you are gazing into the depths of the cosmos, and in the distance, you spot a star not too different from our sun. Orbiting this star, within the perfect distance to support life, is a planet that, though it lies light years away, is one of the closest potential twin worlds to Earth. That planet is Proxima b, and it may hold the key to answering one of humanity's oldest questions. Are we truly alone in the universe? Proxima b is located just 4.24 light years from Earth, making it the closest known exoplanet to our solar system. This proximity, while still vast in terms of distance, brings with it an exciting possibility. In the endless stretch of space, Proxima b lies within the neighborhood of our own cosmic backyard. The fact that this planet resides so close to us means that, in theory, it could be one of the first targets for future space exploration missions. But before we rush to send spacecraft there, let's take a moment to explore what makes Proxima b so intriguing and whether it could actually support life. A glimpse of the surface. Proxima b orbits around Proxima Centauri, the closest star to our Sun. While Proxima Centauri is a red dwarf star, much cooler and dimmer than our Sun, it still emits enough radiation to potentially make Proxima b habitable. This planet lies in the habitable zone of its star, often called the Goldilocks zone. Here, the temperature is just right, not too hot and not too cold, for liquid water to exist on its surface, a key requirement for life as we know it. However, there's one catch. Proxima b is what we call a tidally locked planet. This means that one side of the planet always faces its star, while the other side is in permanent darkness. On the day side, temperatures could be quite high, especially near the equator, where constant sunlight could result in an almost oven-like environment. On the night side, however, the surface could be extremely cold, potentially freezing any liquid water present. Yet, there's hope. The terminator line, the boundary between the day and night sides of the planet, could offer a more temperate climate. This twilight zone, where light and darkness meet, may present conditions that are more suitable for life. This is where the most hospitable environments on Proxima b might exist, where temperatures could allow water to exist in liquid form, and where, perhaps, life could take root. The atmosphere, a protective shield. While the proximity of Proxima b to its star offers the potential for life, it also raises questions about the planet's atmosphere. Red dwarfs like Proxima Centauri are known to have occasional solar flares, massive bursts of radiation that could potentially strip away the atmosphere of a planet orbiting too closely. The strong radiation from these flares could make it difficult for life to survive on the planet's surface, especially if the planet's atmosphere is thin or unstable. However, some scientists believe that Proxima b may still have a magnetic field and a thick atmosphere that could protect it from these solar outbursts. If the planet does have a strong magnetic shield, it would prevent the solar wind from stripping away its atmosphere, just as Earth's magnetic field protects us. Additionally, a thick atmosphere could provide a buffer, regulating temperature and helping to sustain conditions that might allow liquid water to remain stable on the surface. Despite these uncertainties, there's still optimism. In the future, advanced telescopes might be able to analyze Proxima B's atmosphere in greater detail, searching for signs of water vapor, oxygen, or even more complex molecules that could indicate the presence of life. What are the chances for life on Proxima B? With all these factors in mind, the question remains, could Proxima B support life? The potential is certainly there, but it's far from a certainty. As we know, life requires a delicate balance of conditions. Even if Proxima b has water and the right temperature, the presence of harmful radiation and a potentially unstable atmosphere could make it challenging for life to take hold, at least on the surface. That said, there's always the possibility that life could exist in unexpected forms, adapted to the harsh conditions of Proxima b. Perhaps, deep beneath the surface, in the warmth of the planet's interior, microbial life might thrive in the liquid water that exists there. Alternatively, life could exist in the planet's more hospitable twilight zone, where temperatures are less extreme and the conditions are more stable. In some ways, we're only just beginning to scratch the surface of understanding what makes a world habitable, and Proxima b might teach us more than we expect. A gateway to the stars. In the grand scale of the universe, Proxima b is relatively close, closer than any other potentially habitable planet we know of. Because of this, it is a prime candidate for future exploration. The idea of sending a probe or even a crewed mission to Proxima b may sound like science fiction, but with advancements in propulsion technology and space exploration, we might one day see missions that explore this distant world. The Breakthrough Starshot project, for example, is already working on sending tiny, fast moving probes to the Proxima system in just a few decades, even if we cannot visit Proxima b ourselves in the near future. Its proximity and potential for habitability make it an important target in the search for extraterrestrial life. It serves as a reminder that the universe is vast and full of possibilities, and that the answers to some of our biggest questions might be closer than we think. Imagine you're standing on a hill, gazing out across a world that looks eerily similar to Earth. The sky is blue, the sun feels warm, and there's a sense of familiarity in the air. You breathe deeply, only to realize this world is not your own, but one that orbits a distant star. This world is Kepler 452b, a planet that has captured the imagination of scientists and dreamers alike. Located in the Cygnus constellation, Kepler 402b orbits a star that is very much like our own sun, a fact that makes it stand out as one of the most Earth-like planets discovered so far. Kepler 452b is part of the Exoplanet catalog, discovered by NASA's Kepler Space Telescope in 2015, and it's often called Earth's cousin because of the striking similarities it shares with our home planet. It orbits a G-type star, which is virtually identical to our Sun in terms of temperature and brightness. This makes Kepler 452b a prime candidate for studying the possibility of life beyond Earth. A planet that could be our twin. One of the most striking features of Kepler 452b is its size and location. Kepler 452b is about 1.6 times the size of Earth, placing it in the category of what scientists call a super-Earth. Super-Earths are planets that are larger than Earth but still have the potential to support life. While the size difference might sound small, It's significant when considering the planet's surface gravity, atmospheric pressure, and the potential for liquid water. The planet orbits its star at a distance that places it squarely within the habitable zone, that special region where conditions are just right for liquid water to exist. In this way, Kepler 452b is often referred to as an Earth analog. If you were standing on its surface, imagining a future when we might visit, you might feel a strange sense of deja vu. The environment might be similar enough to Earth's that it feels familiar, even though it is located 1,400 light years away. Surface conditions, a world not too different from ours. Kepler 52b's surface conditions are still a matter of great interest and speculation. Because of its size and location in the habitable zone, scientists believe that the planet could have a rocky surface much like Earth. It's likely to have a landscape of continents, oceans, and possibly even polar ice caps. Though we don't know for sure, the surface gravity on Kepler 452b is estimated to be about 1.5 times that of Earth, meaning that a person standing on its surface would weigh about 50% more than they do here. While this might make things feel a little heavier, it wouldn't be enough to make life difficult. The temperature on Kepler 452b would also depend on a variety of factors, including its atmosphere, orbital position, and seasonal changes. If it has an atmosphere like Earth's, temperatures could range from comfortably mild to warm, similar to Earth's temperate climates. The key, as always, lies in the presence of liquid water. If water exists on Kepler 452b, and the chances are high, it could be a planet with lush landscapes, vast oceans, and perhaps the right conditions for life to evolve. The atmosphere. Could it support life? The presence of a protective atmosphere is one of the most important factors when determining if a planet like Kepler 452b could support life. If Kepler 452b has an atmosphere similar to Earth's, it would provide several crucial benefits: temperature regulation, shielding from harmful radiation, and the preservation of liquid water. The exact composition of Kepler 452b's atmosphere is still unknown, but it's likely to be a mixture of gases similar to Earth's, possibly rich in nitrogen, oxygen, and carbon dioxide. With a composition like this, the planet could support the complex processes that are necessary for life, such as photosynthesis and respiration. If Kepler 452b has a thick enough atmosphere, it could also protect its surface from the intense radiation of its star, which is especially important given that the star Kepler 452b orbits is slightly older than our Sun. Interestingly, Kepler 452b's star, Kepler 452, is about 6 billion years old, which is roughly 1.5 billion years older than our Sun. This means the star has been shining longer and has entered a slightly more mature phase of its life cycle. This gives Kepler 452b the potential to have developed conditions conducive to life over a longer period of time. In fact, Kepler 452b could have been in the habitable zone of its star for billions of years, allowing ample time for life to evolve, should it have the right conditions. However, there's a challenge. Kepler 452b's star is aging, and in a few billion years, it will begin to expand, potentially making the conditions on the planet more extreme. But for now, this aging star might offer just the right conditions for a planet like Kepler 452b to support life, perhaps in a way that mirrors Earth's past or present. Resources for life. A rich world. Another important question is whether Kepler 402b could have the resources necessary to sustain life. If the planet has liquid water and a stable atmosphere, there's a strong possibility that it could also have a variety of minerals and chemical compounds essential for the development of life. Earth's surface is rich in carbon, nitrogen, and phosphorus, elements that are fundamental to life as we know it. If Kepler 452b has a similar composition, it could be a world with the right building blocks for life to thrive. Kepler 452b's age also gives it an edge in terms of geological activity. Like Earth, it could have plate tectonics, volcanic activity, and a dynamic surface, which would recycle carbon and other nutrients, contributing to a more stable environment over time. These processes are essential for maintaining long-term habitability, as they help regulate the planet's climate and atmospheric conditions. A future for humanity? While Kepler 452b may be a distant dream for human colonization, its proximity to Earth, in terms of its physical and environmental features, makes it a world of great interest. If the technology allows, future generations might one day look towards planets like Kepler 452b as a possible destination for exploration and even colonization. However, that is still far in the future. For now, Kepler 452b serves as an inspiring example of what is possible in the search for other habitable worlds. It reminds us that, in the vastness of the universe, there are planets that might feel eerily familiar, places that could have conditions not so different from those that allowed life to flourish here on Earth. Imagine a world where the skies are filled with the soft glow of a distant star, its light gentle and warm, yet distinctly different from the sun we know. The landscape before you is alien, but still somehow familiar. In this distant corner of the galaxy, there exists a planet that has sparked wonder and excitement among scientists and astronomers alike. This world is Kepler Y86f, a planet that holds one of the most important clues in our search for life beyond Earth. Located about 500 light years away in the Cygnus constellation, Kepler XF is the first Earth-sized planet discovered within its star's habitable zone. Unlike the other planets we've encountered so far, this one offers something particularly special: the possibility of liquid water. Kepler F orbits a red dwarf star, a much cooler and dimmer star than our Sun, and resides in a region where conditions could allow water to exist in its liquid form. But what does this really mean for the potential of life? Let's journey through the unique features of Kepler 6f, its location in the habitable zone, and its chances of sustaining water and, by extension, life. The habitable zone, a delicate balance. Kepler 186f's most fascinating feature is its position in the habitable zone of its star. As we've learned before, this is the region around a star where temperatures are just right, not too hot and not too cold, for liquid water to exist on the surface. On Earth, we know just how essential water is for life. Whether in oceans, lakes, or rivers, water is the very lifeblood of the ecosystems that thrive on our planet. For Kepler 186f, Being in the habitable zone means that it has the potential to sustain water, possibly even oceans, rivers, or lakes, essential conditions for life as we know it. But this delicate balance is tricky. Kepler 186f orbits its star, which is a red dwarf, at a much closer distance than Earth does to the Sun. Red dwarfs are cooler than our Sun, so the habitable zone around them is much closer to the star. While this closer orbit increases the chances of liquid water existing, it also brings with it challenges. The planet may experience extreme conditions, particularly tidal locking, where one side of the planet always faces its star, while the other side remains in eternal darkness. This could create stark temperature differences between the day and night sides, which might impact the potential for liquid water. Yet, despite these challenges, scientists remain hopeful that Kepler 186f could still maintain liquid water in the twilight zone, the narrow band of land between the eternally hot and cold sides of the planet. In this zone, temperatures could be more moderate and water could remain liquid, perhaps even sustaining ecosystems much like those on Earth's temperate latitudes. Could water exist in liquid form? For any planet to support life, liquid water is a non negotiable requirement. Without it, the biochemical processes that sustain life, such as the transportation of nutrients and waste, cannot function properly. Kepler 186f, located within the habitable zone of its red dwarf star, has the potential for liquid water, but a lot depends on its atmosphere. If Kepler has a thick atmosphere, it could act as a protective blanket, keeping the surface warm enough for liquid water to remain stable. The composition of this atmosphere is unknown, but scientists speculate that it might be rich in gases like carbon dioxide, nitrogen, and oxygen, elements that could help regulate temperature and protect against harmful radiation from the star. This atmosphere would also act as a shield, preventing the solar wind from stripping away any water molecules that might be present. The key question is whether the planet's atmosphere is thick enough to create greenhouse conditions, warming the surface just enough for liquid water to remain stable. If the atmosphere is too thin, the planet could suffer from extreme cold with temperatures that would cause any surface water to freeze. On the other hand, if the atmosphere is too thick, the planet could experience a runaway greenhouse effect, similar to Venus, where temperatures rise to levels too high to sustain liquid water. One possible scenario for Kepler 186f is that it might have water beneath its surface, either trapped in underground reservoirs or hidden within an icy crust. If that's the case, microbial life might exist in subterranean oceans or pockets of liquid water, much like some of the most resilient forms of life here on Earth. In this way, even if surface water is scarce or fleeting, Kepler 186f could still harbor life in more sheltered environments. What's beneath the surface? It's important to remember that when we search for signs of life on planets like Kepler 186f, we are often looking at the potential for life rather than direct evidence. The surface of Kepler may hold the key to understanding how life could emerge on a planet orbiting a red dwarf star. While the surface may be subject to extremes, the subsurface environment might offer a more stable, protected habitat for life to thrive. This is the same principle behind Earth's deep oceans, where life flourishes despite the lack of sunlight. The deeper regions of Kepler uh, could provide just the right conditions for microbial life to survive, shielded from the harsh radiation of the star, with access to water and minerals from the planet's interior, a world that could be just like Earth. Kepler F is a remarkable world in many ways. Though it is not exactly the same as Earth, it shares many similarities, particularly in its size and position in the habitable zone of its star. It is roughly 1.1 times the size of Earth, placing it in the category of Earth like exoplanets. This size is significant because it suggests that Kepler 186f has the potential for a rocky surface with the right conditions for liquid water and possibly life. What makes Kepler 186f so intriguing is that, even though it is located in the habitable zone of a red dwarf star, the conditions on the planet could be more similar to Earth than we might initially expect. The key to its potential habitability lies in its atmosphere and the presence of liquid water, both of which remain a mystery, but both of which could turn out to be crucial factors in determining whether life could exist. A glimpse into our cosmic future. Although Kepler 186f is located far beyond our reach, 500 light years from Earth, its discovery has inspired scientists and space enthusiasts alike. The possibility that this planet could support liquid water, and by extension, life, makes it one of the most exciting exoplanets in the search for other worlds like our own. As we continue to search the stars for planets that could support life, Kepler 186f serves as a reminder of how much we have yet to discover about the universe. It's a world that could be just like Earth, or perhaps, in its own unique way, even more remarkable than we ever imagined. Imagine standing on the rocky surface of a distant world, gazing out at the heavens. The sky, though darker and perhaps a little closer to the horizon than on Earth, is still filled with distant stars, a reminder that you're far from home. Below your feet, the ground is solid and firm, a deep, metallic density that hints at the planet's ancient formation. You're on LHS 1140b, a world that lies approximately 40 light years away in the constellation Phoenix, orbiting a cool red dwarf star. Though distant, LHS 1140b is one of the most promising planets scientists have discovered, offering a rare combination of size, density, and location that could make it a key candidate for the search for life, a world of stone and metal. The density of LHS 1140b. One of the most intriguing aspects of LHS 1140b is its density. This planet is about 1.4 times the size of Earth, but is also significantly more massive, weighing in at about 6.6 times the mass of Earth. This means that LHS 1140b has a much higher density, indicating that its composition is likely very different from that of Earth. While Earth is a mix of rock, metals, and water, LHS 1140b likely contains more metal-rich minerals, perhaps with a large iron-nickel core, and a rocky surface that could be quite inhospitable to life as we know it. But this higher density also has important implications for the planet's geological activity. A planet with this much mass is likely to have significant internal heat, potentially driving volcanic activity and plate tectonics. This kind of geological dynamism is essential for maintaining a stable environment over long periods of time, as it helps regulate the planet's temperature and recycle critical minerals. On Earth, plate tectonics play a huge role in sustaining life, particularly by regulating the carbon cycle, which keeps our atmosphere in balance. If LHS 1140b has similar geological activity, it could have the conditions necessary for long term habitability, even if life on the planet evolved in a way that is completely different from our own. The atmosphere, could it support life? Like any planet, the ability of LHS 1140b to sustain life depends heavily on the composition of its atmosphere. Given the planet's higher density and size, LHS 1140b likely has a substantial atmosphere, which is good news for the possibility of liquid water and a stable environment. However, the exact composition of this atmosphere is still a subject of great speculation. The planet orbits a red dwarf star, which, like other red dwarfs, is cooler and less luminous than our Sun. This means that LHS 1140b resides in a habitable zone closer to its star than Earth does to the Sun. While this proximity increases the likelihood that the planet could sustain liquid water, it also means that the planet is likely to experience higher levels of stellar radiation. Red dwarfs are known to emit intense solar flares, which could strip away the atmosphere of a planet that is too close, making it difficult for life to survive. However, LHS 1140b is located far enough from its star that it might still be able to retain a protective atmosphere. Some scientists speculate that the planet could have a thick atmosphere made up of carbon dioxide, nitrogen, and oxygen, similar to Earth's atmosphere, but with potentially higher concentrations of CO, which could help trap heat and maintain surface temperatures that support liquid water. There is also the possibility that LHS 1140 could have a strong magnetic field, which would provide a shield from harmful stellar radiation, just as Earth's magnetic field protects us from solar flares and cosmic radiation. If the planet's magnetic field is strong enough, it could allow the atmosphere to remain intact and create conditions conducive to life, much as Earth's atmosphere has done for billions of years. Hypothetical life on LHS 1140b. Given its size, composition, and potential atmosphere, LHS 1140b could hypothetically support life, but the form of that life might look very different from anything we know. Earth life depends on a specific set of conditions: liquid water, a stable atmosphere, and a mild range of temperatures. LHS 1140b seems to have the potential for these conditions, but there are a number of unknowns that make its habitability uncertain. The possibility of life as we know it on LHS 1140b is not guaranteed, but there is hope that life could have evolved in ways that are suited to the planet's environment. For example, if the planet has oceans or subterranean water reserves, microbial life could exist, much like the extremophiles here on Earth that thrive in extreme environments like deep sea vents or acidic lakes. These organisms have evolved to survive without sunlight, using alternative forms of energy such as chemical reactions. Similarly, life on LHS 40b might have adapted to the unique conditions of the planet, using heat from the planet's interior or energy from its star in ways that we have yet to fully understand. In fact, LHS 1140b might be a planet where life has adapted to conditions quite different from Earth's surface-dwelling organisms. The planet's geological activity and potential for a thick atmosphere might make its subsurface environments particularly promising. Perhaps life, if it exists, resides in deep oceans heated by volcanic activity, shielded from the harsh surface conditions by thick layers of rock or ice. Such a scenario would mirror some of the most extreme environments on Earth, where life thrives in places that were once thought to be inhospitable. Exploring LHS 1140b, a planet worth investigating. LHS 1140b has already been the subject of much excitement and study. It is one of the best candidates for further exploration, and its relatively close proximity to Earth means that, with future advancements in technology, we could be able to study it in greater detail. Instruments like the James Webb Space Telescope may one day be able to analyze the atmosphere of LHS 1140b for signs of life, or more likely, signs of conditions that could support life. The possibility of detecting biosignatures, molecules like oxygen, methane, or ozone that might indicate biological processes, is a tantalizing goal. Whether or not life exists on LHS 1140b, its unique characteristics make it an essential object of study in our quest to understand the diversity of worlds that could harbor life. The planet serves as a reminder that even though our own world may be the only one we know to sustain life, the universe holds countless other planets that might share key features with Earth, or offer a surprising new definition of what life can be. Nestled in the depths of space, about 40 light years from Earth, lies the TRAPPIST-1 system, a captivating stellar system that has sparked the imagination of astronomers and space enthusiasts alike. This system is home to 7 Earth-sized planets orbiting a single cool red dwarf star. One of the most interesting planets in this system is TRAPPIST-1d, a world that lies within its star's habitable zone and could potentially harbor liquid water, a key ingredient for life. The TRAPPIST-1 system is special because it has a compact configuration of planets, all orbiting their parent star much closer than Earth orbits the Sun. Despite this, several of these planets, including TRAPPIST-1d, have sparked intense scientific interest because they lie within the habitable zone where life-supporting conditions could exist. TRAPPIST-1d is one of the most promising candidates in this system for supporting life. So let's take a closer look at what makes this planet so extraordinary. A compact and intriguing planetary system, the TRAPPIST-1 system is unlike any planetary system we know in our immediate vicinity. Its red dwarf star, TRAPPIST-1, is cooler and dimmer than our Sun, meaning that the habitable zone around this star is much closer to the star itself. In fact, the planets in this system orbit extremely close to TRAPPIST-1, with their orbital periods ranging from just 1.5 to 12.4 Earth days. This compact configuration makes the system intriguing from a scientific standpoint because it allows astronomers to study multiple planets in the habitable zone of the same star. All 7 of the TRAPPIST-1 planets are about the size of Earth, and their similar sizes make it easier for scientists to compare their characteristics and potential for habitability. The planets are tidally locked, meaning one side always faces the star, while the other side remains in perpetual darkness. This results in an interesting and extreme climate. One side might be scorching hot, while the other is frigidly cold. But in the twilight zone, the region between the eternal day and night sides, temperatures could be more moderate, possibly allowing liquid water to exist. TRAPPIST 1d, a planet in the sweet spot. Out of the 7 planets in the TRAPPIST 1 system, TRAPPIST 1d stands out for being positioned in its star's habitable zone. It is roughly 1.1 times the size of Earth, placing it firmly in the category of Earth-sized exoplanets. With a relatively similar mass and density to Earth, TRAPPIST 1d may have a rocky surface, similar to our own planet. This is an important factor because it suggests that the planet could potentially have the right conditions for the formation of liquid water, which is considered essential for life as we know it. What's more, TRAPPIST 1d's position in the habitable zone means it is in the right place for water to remain in its liquid state. Because its host star is much cooler than the Sun, TRAPPIST 1d is located closer to its star than Earth is to the Sun. But this doesn't mean the planet would be unbearably hot. Far from it. The relatively low luminosity of the red dwarf star means that temperatures on TRAPPIST 1d could range within a livable zone, especially in the twilight zone, where the temperatures would not be too extreme. Could water exist on TRAPPIST 1d? Water is often cited as the golden ticket for life, and for TRAPPIST 1d, the possibility of liquid water is one of the most exciting aspects of its potential habitability. If TRAPPIST 1d has a thick atmosphere, the greenhouse effect could help regulate temperatures and create a stable environment where liquid water could flow. This would require a delicate balance, however. The atmosphere would need to be dense enough to trap heat, but not so dense that the planet experiences a runaway greenhouse effect, like Venus. A thick atmosphere could also shield the planet's surface from harmful radiation emitted by its red dwarf star. While red dwarfs are known to emit intense solar flares, TRAPPIST 1d's atmosphere could act as a protective barrier, similar to how Earth's atmosphere shields us from the sun's harmful rays. If the atmosphere contains the right mix of gases, like carbon dioxide, nitrogen, and oxygen, it could keep the planet warm enough to sustain liquid water and possibly even life. Interestingly, TRAPPIST 1d has been identified as a candidate for atmospheric analysis by upcoming telescopes, including the James Webb Space Telescope. This could allow scientists to better understand the planet's atmosphere and search for signs of biosignatures, the chemical markers that could indicate the presence of life. Geological and environmental conditions. A rocky, dynamic world. Another factor that could make TRAPPIST 1d an intriguing world for life is its geological composition. Given its size and density, the planet likely has a rocky surface and possibly an iron-rich core. This suggests that TRAPPIST 1d could have volcanic activity or even tectonic movement, which would be important for recycling nutrients and maintaining a dynamic environment. In addition to its rocky surface, the presence of water, whether in oceans or underground reservoirs, could also promote a dynamic, ever-changing landscape. Plate tectonics and volcanic activity help regulate the planet's temperature over time by releasing gases into the atmosphere and removing excess carbon dioxide. If TRAPPIST 1d has similar processes at play, it could help maintain the delicate balance needed to support life. Moreover, Its tidal locking could create unique environmental conditions. The day side of the planet would likely be very hot, while the night side would be cold. But in the twilight zone, where the day and night sides meet, the temperature could be just right for liquid water to persist. If life were to evolve on TRAPPIST 1D, it might be found in the more temperate regions, where conditions are more stable. Life on TRAPPIST 1D, a unique possibility. The question of whether life could exist on TRAPPIST 1D remains an open one. It is certainly possible that microbial life could thrive in the planet's more temperate regions, especially if liquid water is present. The existence of a stable atmosphere, liquid water, and the right chemical ingredients would be necessary for life to develop. However, whether life would evolve similarly to life on Earth or in an entirely different form is still unknown. If life does exist, it could take forms that are radically different from what we are used to. Just as Earth has microbes that live in extreme conditions, such as in the boiling water of hydrothermal vents, life on TRAPPIST 1D could have adapted to the planet's unique environment. Perhaps life exists beneath the surface, in hidden pockets of water shielded from the harsh radiation, or maybe it thrives in the twilight zone, where conditions are more balanced and stable. A glimpse of hope in the search for life. In the end, TRAPPIST 1D is a beacon of possibility in our quest to find life beyond Earth. While there are still many unknowns about this distant world, the potential for habitability makes it one of the most exciting planets to study. The combination of its size, location in the habitable zone, and the possibility of liquid water opens up a world of scientific discovery. As we continue to search the stars for signs of life, TRAPPIST 1D reminds us of how much we have yet to learn. Its discovery is a testament to the wonders that await us, a world where, just maybe, life could exist, waiting to be discovered by future explorers. A quiet star, far from the bustling center of the Milky Way, flickers in the dark expanse of space. Around it orbits Ross 128b, a planet that stands out in the sea of exoplanets due to its remarkable proximity to our own solar system. At just 11 light years away, Ross 128b is one of the closest potentially habitable planets that we know of, making it an enticing target for future study. For centuries, humanity has searched the stars, wondering if we are truly alone in the vast expanse of the universe. Ross 128b might just be the answer to that question. Ross 128b orbits a red dwarf star, Ross 128, which is much cooler and smaller than our Sun. This star is located in the constellation Virgo, far from our solar system, but still relatively close in cosmic terms. The planet orbits its star in a way that places it squarely in the habitable zone, where conditions could allow liquid water to exist on its surface. It's the combination of its location, its size, and the possibility of water that make Ross 128b such an exciting prospect for those hoping to find life beyond Earth. A world so close, yet so far. The proximity of Ross b. At just 11 light years from Earth, Ross b is among the closest Earth-like exoplanets we know of. In cosmic terms, that's a mere stone's throw away. This proximity offers a rare opportunity for astronomers to study the planet in great detail, something that is not always possible with exoplanets located hundreds or even thousands of light years away. Its relatively close distance makes it an excellent candidate for upcoming space telescopes, such as the James Webb Space Telescope, JWST, to examine its atmosphere and surface conditions. The fact that it is located so near to us gives humanity a rare glimpse into the diversity of planets that orbit other stars. While it is still too far to visit with current technology, the ability to study Ross 128b up close could provide vital clues about the conditions necessary for life to emerge and thrive on a planet outside of our solar system. Surface conditions. Could life thrive on Ross 128b? Given that Ross 1b resides within its star's habitable zone, one of the most crucial factors for supporting life, it's important to consider the planet's surface conditions. The habitable zone, or the Goldilocks zone, is the region around a star where temperatures are just right for liquid water to exist, not too hot and not too cold. The fact that Ross 128b lies within this zone means that, in theory, water could flow on its surface, which is one of the fundamental requirements for life as we understand it. The surface conditions on Ross 1b, however, depend largely on the composition of its atmosphere and the stellar radiation from its host star, Ross 128. While red dwarf stars like Ross 128 are cooler and dimmer than our Sun, they often emit intense stellar flares that could affect the planet's atmosphere. Such flares could strip away the atmosphere if the planet is too close, making it challenging for life to survive. However, Ross 128b is located far enough from its star that it might avoid this fate. If Ross 128b has a thick atmosphere capable of protecting its surface from radiation, this would go a long way toward creating a stable environment that could sustain liquid water and, by extension, life. The planet's atmosphere would also need to regulate temperatures effectively. Just as Earth's atmosphere traps heat and maintains a comfortable average temperature, Ross 128b's atmosphere would need to have a delicate balance of greenhouse gases like carbon dioxide and nitrogen to create a livable environment. Another possibility for Ross 128b is that its atmosphere could be rich in oxygen and nitrogen, similar to Earth's. This would be an important factor in making the planet more Earth-like, providing the necessary conditions for the evolution of complex life forms. Scientists are particularly excited about the potential for studying Ross 128b's atmosphere in the coming years, as it could reveal whether or not such biosignatures exist, geological activity, and habitability. Given that Ross 128b is a rocky exoplanet, much like Earth, its surface might resemble ours in some ways. The planet is about 1.35 times the size of Earth, which suggests that it may have a similar geological composition. It's possible that Ross 128b could have volcanic activity or even plate tectonics, both of which play important roles in Earth's long-term habitability by regulating temperatures and cycling essential elements through the planet's systems. However, much of this remains speculative, without direct evidence from telescopes or future space missions. We cannot yet say for sure what the surface of Ross 128b looks like. It could have vast oceans, a land-covered surface, or even a frozen world. Whatever its surface conditions, if it does support life, It would most likely be microbial, similar to the extremophiles on Earth that can survive in harsh, high pressure environments like the deep ocean or volcanic vents. The allure of Ross 128 b for humanity. One of the most appealing aspects of Ross 128b is its potential to host life. As humans continue to search for extraterrestrial life, planets like Ross 1b provide tantalizing clues about the possibilities of life beyond Earth. The relatively close proximity of the planet allows us to study it with the most advanced telescopes available, and future missions might be able to probe its atmosphere for signs of biosignatures, the telltale signs of life. For humanity, the discovery of life on Ross 128b, or even the mere possibility of life, would have profound implications. It would suggest that the conditions for life are not unique to Earth and could be found across the galaxy. The discovery of even microbial life on Ross 128b would answer one of the greatest questions humanity has ever asked: are we alone in the universe? But the allure of Ross 128b isn't just about finding life, it also represents a step toward a greater understanding of how planets evolve, what factors are necessary for habitability, and how we might one day establish a presence on planets outside our solar system. In the distant future, as space exploration advances, planets like Ross 28b could become potential targets for human colonization or long-term study. The knowledge gained from studying such exoplanets could also provide insights into how to preserve and protect Earth's own environment, a planet to watch in the search for life. The potential for Ross 128 support life makes it one of the most exciting exoplanets to monitor in the coming years. As we continue to refine our observational techniques and develop more powerful telescopes, the study of this planet will likely yield new insights into the conditions that make a planet habitable. Whether or not life exists on Ross 128b, it serves as a symbol of the possibilities that await humanity in the search for life beyond Earth. The allure of Ross 128b is undeniable. Its proximity to Earth, combined with its location in the habitable zone and its Earth-like characteristics, makes it a prime candidate for future exploration and a tantalizing subject for scientists eager to answer one of the biggest questions of our time. Are we alone in the universe? At a distance of about 124 light years from Earth, orbiting a red dwarf star in the constellation Leo K2-18b, is an intriguing world that has become the subject of intense study in recent years. Discovered during NASA's Kepler mission, K2-18b is part of a class of planets known as super-Earths, planets that are larger than Earth but smaller than Uranus or Neptune. This exoplanet lies in its star's habitable zone, making it one of the more compelling candidates in the ongoing search for life beyond our solar system. The significance of K18b isn't just in its size or location, it's the recent discovery that the planet's atmosphere contains water vapor. This discovery has set the scientific community abuzz with excitement, as water is considered one of the essential ingredients for life. Let's explore why K2-18b is such a key player in the search for habitable worlds. The discovery of water vapor. In 2019, astronomers made a groundbreaking announcement that they had detected water vapor in the atmosphere of K2-18b. This discovery was made using the Hubble Space Telescope, which observed the planet's atmosphere as it passed in front of its parent star. By analyzing the light that passed through the atmosphere, scientists were able to identify the signature of water vapor, a key ingredient for life. The presence of water vapor is significant because it suggests that liquid water could exist on the planet's surface or beneath its clouds. This is crucial for the potential of habitability. While the discovery of water vapor doesn't automatically mean that life exists on K218b, it does imply that the planet might have the right conditions to support life. The next step for scientists will be to investigate whether the water is part of a stable, long-term hydrological cycle, just as we see on Earth, or whether it exists only in trace amounts. K28b's atmosphere, a closer look. K218b has a mass about 8.6 times that of Earth and is roughly 2.6 times the size of Earth, placing it firmly in the super-Earth category. Its size suggests that it likely has a thick atmosphere, possibly composed of hydrogen and helium, with a mixture of water vapor, carbon dioxide, and other gases. This dense atmosphere could help trap heat, maintaining temperatures that might allow for liquid water to exist on the surface. One of the exciting aspects of K218b's atmosphere is that, in addition to water vapor, scientists have speculated that it could also contain clouds and even rain. This would further suggest that the planet has a functioning hydrological cycle, similar to Earth's water cycle, with the potential for rivers, oceans, and lakes on its surface. If this is the case, K218b could have the necessary conditions for sustaining life. Could life exist on K218b? The question that is on everyone's mind is whether life could exist on K218b. While the presence of water vapor is an exciting indicator, there are many other factors that contribute to a planet's ability to support life. For example, the planet's surface temperature would need to be within a range that allows liquid water to exist, not too hot and not too cold. Given that K218b is located in the habitable zone of its parent star, the conditions might be just right. However, much like other exoplanets, this depends on the exact nature of the planet's atmosphere and its ability to retain heat without becoming too extreme. The existence of greenhouse gases, like carbon dioxide, could help regulate the planet's temperature, making it possible for liquid water to flow on its surface, much like Earth. It's important to note that K218b is quite different from Earth in one key way. It is a super-Earth, which typically have higher atmospheric pressures and gravity than our planet. This could mean that any life forms on K218b would need to be adapted to these more extreme conditions. The high pressure could also affect the planet's ability to support life as we know it. In addition, super-Earths may have thick, potentially toxic atmospheres, or the atmospheric pressure might be too high to support complex life forms like those on Earth. Despite these differences, scientists have speculated that microbial life, similar to extremophiles on Earth, could survive in the planet's liquid water. Extremophiles are microorganisms that thrive in extreme environments, such as deep-sea hydrothermal vents or acidic hot springs. If life exists on K218b, it might take a form that is very different from what we see on Earth, but could still be based on the same biochemical principles. Surface conditions, a mysterious world. We don't yet know what the surface of K2-18b looks like, but we can make some educated guesses. Given its size, K2-18b is likely to have a thick, dense atmosphere, which would make the planet's surface conditions very different from Earth's. The atmosphere could create strong winds, high atmospheric pressure, and temperatures that might vary widely depending on the planet's distance from its star and the composition of its clouds. The thick atmosphere of K2-18b could also contribute to the greenhouse effect, trapping heat and warming the surface. This could help maintain liquid water, which is crucial for life. However, this same greenhouse effect could also lead to extreme temperatures in some areas, making the planet's surface inhospitable in certain regions. Given the planet's distance from its star and the nature of red dwarfs, K2-18b might experience intense stellar activity, such as solar flares and radiation bursts. If the planet's atmosphere is thick enough to protect its surface from these solar flares, it might create a stable environment for life. If not, the planet might face conditions too harsh for any life forms to survive. K2-18b, a world of possibilities. K2-18b is a super Earth in the habitable zone of its star, with water vapor in its atmosphere and the potential for liquid water on its surface. While we still don't have definitive proof that life exists on this distant world, the discovery of water vapor makes it one of the most intriguing exoplanets in our search for extraterrestrial life. The planet's atmospheric composition, its size, and its location in the habitable zone all make it a promising candidate for future studies. It's also one of the best examples of how advanced technologies, like the Hubble Space Telescope and upcoming missions, can help us unlock the mysteries of distant planets. By analyzing the atmosphere of K2-18b in greater detail, scientists hope to learn more about its potential for life and the conditions that could support it. If humanity ever manages to reach this distant world, K2-18b could become a stepping stone for exploration, not just for its potential to support life, but also for the insights it could provide into how planets and atmospheres evolve and what conditions are required for life to thrive. In the quiet corner of the constellation Aries, Teegarden's star, a red dwarf star, holds within its gravitational grasp a planet that could change our understanding of the cosmos. Teegarden's star B is an exoplanet that orbits this faint, relatively cool star, located only 12.5 light years away from Earth. While it's not the closest exoplanet we've discovered, it is one of the most promising in terms of habitability. Teegarden's star is much cooler and dimmer than our Sun, which makes Teegarden's star B's position in its habitable zone even more intriguing. The star's habitable zone, the region where temperatures are just right for liquid water to exist, is closer to the star than Earth's orbit is to the Sun, which means that the planet must orbit at a relatively close distance to its parent star. Despite the star's dimness, this close orbit places Teegarden's star B in an area that could potentially support life. The orbit and temperature of Teegarden's star. Teegarden's star B orbits its parent star in just less than 5 days, which means its orbit is extremely close to its star. This rapid orbit is typical for planets around red dwarf stars, which are much smaller and cooler than our Sun. The proximity to the star, while placing the planet in the habitable zone, also raises questions about the possibility of tidal locking, a phenomenon where one side of the planet always faces the star while the other side remains in constant darkness. Tidal locking can have significant implications for a planet's habitability. If Teegarden's star B is indeed tidally locked, the side facing the star would experience extreme heat, while the far side could be freezing cold. This might make the planet's surface conditions more extreme than on Earth. However, in some cases, the presence of an atmosphere and ocean currents can help distribute heat around the planet, potentially allowing for more temperate condition at the terminator, the boundary between the day and night sides. In fact, recent studies suggest that planets around red dwarfs may have the potential for moderate climates, even if they are tidally locked. As for the expected temperature of Teegarden star B, scientists believe that the planet's proximity to its star, combined with its size and potential atmosphere, places it within a temperature range where liquid water could exist. The effective temperature of the planet, which takes into account the amount of light it receives from its star, suggests that the planet may be warm enough to support water in liquid form. However, this depends on the planet's atmospheric conditions, such as the presence of greenhouse gases, which could trap heat and regulate temperatures, making it more Earth-like. Given that Teegarden's star is a red dwarf, its star's stellar activity is an important factor to consider. Red dwarfs are known to emit flares, which could bombard nearby planets with intense radiation. If Teegarden's star B has a strong magnetic field and thick atmosphere, it could potentially shield itself from the harmful radiation, creating a more stable environment on the surface. Habitability, a world with potential. The habitability of Teegarden's star B hinges on several factors, including its atmosphere, water presence, and its ability to withstand the environmental challenges posed by its star. The fact that the planet is located in the habitable zone is a strong indicator that it could have the right conditions for life. But much like other exoplanets, whether it can truly sustain life depends on several unknowns. As we know, liquid water is essential for life as we understand it. The fact that Teegarden star B's surface temperature could allow liquid water to exist makes it one of the more intriguing exoplanets in the search for life. However, the planet's atmosphere is crucial in determining whether or not it can retain this water in a liquid state. If the planet lacks a significant atmosphere, the water could quickly evaporate or freeze. If the atmosphere is thick and rich in greenhouse gases, it could create a stable climate where water exists as a liquid. Atmosphere and composition. The building blocks of life. Teegarden star B is thought to be a rocky planet with a size similar to Earth, which means it could have an atmosphere capable of sustaining life. However, the nature of this atmosphere remains a mystery. A thick atmosphere made of gases like nitrogen, carbon dioxide, and oxygen in the right proportions would be essential for creating Earth-like conditions. If the planet's atmosphere is thin or composed mostly of hydrogen and helium, it might be unable to trap heat or sustain liquid water on the surface. Furthermore, a major concern with planets orbiting red dwarf stars is that these stars are prone to stellar flares, which could strip away the atmosphere of a nearby planet over time. If Teegarden star B is exposed to frequent flares, This could threaten the planet's habitability by depleting its atmosphere and exposing the surface to harmful radiation. However, red dwarf stars can also be much more stable than their more massive counterparts, so the effect of flares on Teagardens star B would depend on its orbital dynamics and the distance from its star. There is also the possibility that Teagardens star B could have volcanic activity, which could play a role in sustaining life. On Earth, volcanic activity releases gases like carbon dioxide and sulfur dioxide into the atmosphere, which are essential for the planet's long term habitability. If Teagardens star B is geologically active, it could help replenish the gases necessary for maintaining a stable climate. What makes Teagardens star B special? What makes Teagardens star B stand out in the vast landscape of exoplanet discoveries is its potential to be an Earth like world orbiting a red dwarf star. While red dwarfs are often considered more challenging targets for habitability due to their stellar flares and potential for tidal locking, Teagardens star B shows that planets around these stars can still be viable candidates for life. The proximity of the planet to its star, combined with its potential to harbor liquid water, places it among the top contenders in our search for extraterrestrial life. Although we don't yet know whether this world has an atmosphere conducive to life, its size and location make it a strong candidate for future study. The planet's closeness to Earth, just 12.5 light years, means that it is within reach for next generation telescopes and missions aimed at studying exoplanets in detail. Conclusion: a planet full of potential, Teagardens star may not be as well known as some of its counterparts, but it has captured the imagination of astronomers due to its size, orbital position, and potential for habitability. Its orbit within the habitable zone, its likely rocky composition, and its proximity to Earth all make it an excellent candidate for further study. As we continue to explore exoplanets, Teagardens star B stands as a reminder that life could exist in the most unexpected corners of the universe, and its story is far from finished. Located about 14 light years away in the constellation of Ophiuchus, Wolf 1061c is part of a three-planet system orbiting the star Wolf 1061, a red dwarf that is much cooler and less luminous than our Sun. Despite being relatively nearby in galactic terms, Wolf 1061c's true significance comes from its position in the habitable zone of its star, the region where conditions might be just right for liquid water to exist on the planet's surface, one of the key ingredients for life as we know it. Wolf 1061 itself is a much older star, estimated to be about 7 to 8 billion years old, which means that planets like Wolf 1061's could have had billions of years to develop conditions conducive to life. This provides an intriguing opportunity to study a planet that may have had a significantly longer period to evolve than Earth. Wolf 1061 is a super-Earth, roughly 1.4 times the size of Earth, which means that it's likely to have a rocky composition. While this makes it more massive than our planet, it also means that the planet could potentially have a thicker atmosphere, which could help to trap heat and maintain a more Earth-like climate. Let's explore this fascinating world in more detail. Position in the habitable zone. Wolf 1061 C's position in the habitable zone is one of its most significant features. The habitable zone, also known as the Goldilocks zone, is the range of distances from a star where conditions are not too hot and not too cold, just right for liquid water to exist on a planet's surface. Wolf 1061 C's distance from its parent star places it squarely within this region. Unlike Earth, which is located at a relatively moderate distance from the Sun, Wolf 1061 is much closer to its star because red dwarfs are much dimmer than stars like our Sun. The habitable zone around Wolf 1061 is much closer to the star than our Sun's habitable zone, which means that Wolf 1061c orbits its star at a distance of approximately 0.08 AU astronomical units, much closer than Earth's 1 AU. Despite this close proximity, the planet is still within the temperature range where liquid water could be present, thanks to the dimmer light emitted by its parent star. The fact that Wolf 1061 is in the habitable zone means that it is one of the most promising exoplanets for further study in the search for life. If the planet has the right atmosphere, it could have temperate surface conditions that would allow for liquid water to exist, which is crucial for life as we know it. Interesting data and observations, size and composition. Wolf C is classified as a super Earth with a size about 1.4 times that of Earth. This suggests that the planet is likely rocky, with a solid surface, which is an important factor for habitability. Being a super Earth, Wolf 1061 could have a thicker atmosphere than Earth, which would help it retain heat and maintain more stable temperatures. This would increase the likelihood of liquid water existing on its surface. Orbital characteristics. The planet completes an orbit around Wolf 1061 in about 13.5 days, which is much shorter than Earth's orbital period of 365 days. Given that the planet orbits a red dwarf star, its relatively quick orbit indicates that it is much closer to its star than Earth is to the Sun. Despite this, Wolf 1061 is still positioned in the habitable zone, making it a strong candidate for liquid water, assuming it has the right atmospheric conditions. Atmosphere and climate. The nature of Wolf 1061's atmosphere is still unknown, but scientists suspect that as a super Earth, it could have a relatively thick atmosphere. Such an atmosphere could help regulate the planet's temperature by trapping heat from the star. For this reason, even though Wolf 1061 is closer to its star than Earth is to the Sun, its atmospheric composition might allow for conditions suitable for life. A greenhouse effect, driven by gases like carbon dioxide or water vapor, could maintain surface temperatures within the range necessary to support liquid water. However, the exact compositions of the atmosphere remains uncertain. If it is rich in nitrogen and oxygen or contains the right balance of greenhouse gases, it could create Earth-like conditions. On the other hand, if the planet's atmosphere is too thick or contains large amounts of carbon dioxide or methane, it could lead to a runaway greenhouse effect, which would raise temperatures to uninhabitable levels, similar to what we see on Venus. Stellar activity and radiation. One potential challenge for Wolf 1061c is the fact that it orbits a red dwarf star. While red dwarfs are long-lived, they are also known to emit intense stellar flares, which could release large amounts of radiation into nearby planets' atmospheres. These flares could strip away the atmosphere of Wolf 1061c over time, making it less likely to support life. However, if the planet has a strong magnetic field, it could protect itself from the worst effects of this radiation, much like Earth's magnetic field protects us from solar radiation. Potential for life. The most exciting aspect of Wolf 1061 is its potential to support life. Its position in the habitable zone, combined with its size and possible atmosphere, makes it one of the most promising exoplanets in terms of habitability. The presence of liquid water, combined with the right atmospheric and surface conditions, could create a world capable of supporting life as we know it. However, much like other exoplanets, we don't yet have enough information to say for certain whether life could exist there, but the potential is certainly there. Wolf 1061, a key candidate in the search for life. Wolf 1061c is a super Earth located in the habitable zone of a red dwarf star. With a size just over 1.4 times that of Earth, the planet could have the right atmospheric conditions to support liquid water, one of the most critical ingredients for life. The planet's proximity to its star, though relatively close, places it in the right range for potentially Earth-like surface temperatures. While there are still many unknowns about its atmosphere and surface conditions, the fact that it resides in the habitable zone of a nearby red dwarf star makes it an exciting target for future observations. Advances in technology, such as next-generation telescopes and atmospheric analysis, may one day allow us to study the planet in detail and uncover whether it could sustain life. The discovery of planets like Wolf 1061c gives us hope that life could exist on planets orbiting red dwarfs, which are some of the most abundant stars in the galaxy. With its position in the habitable zone, its likely rocky composition, and its proximity to Earth, Wolf 1061 is one of the more promising exoplanets in our ongoing search for extraterrestrial life. Located about 23.6 light years from Earth in the constellation of Scorpius, Gliese 67c is part of the Gliese 67 system, which consists of three stars. The star that Gliese 67cc orbits, Gliese 67c, is a red dwarf star, similar to many of the stars that host the exoplanets we've already explored. However, despite its dimness, this star is of great interest because of its stable environment and the planets that orbit it. Gliese 667a is one of the planets in this system that resides in the habitable zone of its star. This planet is a super Earth, meaning that it is larger than Earth, but likely rocky in composition. With a mass approximately 4.5 times that of Earth, Gliese 67 sits comfortably in the size range of super Earths that are most often found in habitable zones. Its orbital period is around 28 days, a relatively short period compared to Earth's year, but it still falls within the region where conditions could be suitable for liquid water to exist on its surface. Let's break down the details that make Gliese 667c a key contender in the search for life. Earth-like characteristics. Gliese 6 shares a number of key characteristics with Earth, which makes it stand out in the ongoing search for exoplanets that could host life. These characteristics include 1. Size and composition. Gliese 667 cc is about 1.5 times the size of Earth and is thought to be a rocky planet, just like our own. A rocky composition is one of the most important factors for determining whether a planet could support life, as it suggests that the planet has a solid surface, which could potentially support the development of land based life forms. The fact that it is a super Earth suggests it may have a higher gravity than Earth, but it is not large enough to be a gas giant like Uranus or Neptune. 2. Atmosphere. As a rocky planet, Gliese 667 is likely to have an atmosphere, which would be crucial for supporting life. The composition and thickness of this atmosphere are still unknown, but if it contains gases such as nitrogen, oxygen, and carbon dioxide in the right proportions, it could create a stable environment where temperatures are regulated and liquid water can exist on the surface. Additionally, the atmosphere would help shield the planet's surface from harmful radiation. 3. Temperature. Gliese 667 cc's location within the habitable zone of its star means that it is in the right position for liquid water to exist, assuming it has an atmosphere to retain heat. The effective temperature of the planet, which takes into account the star's luminosity and distance, suggests that it could have surface temperatures in the range where liquid water could exist, which is one of the key ingredients for life. While we don't yet know the exact temperature of the planet's surface, it is certainly in the right zone to sustain life. 4. Orbit and stability. One of the most important factors in determining whether a planet could sustain life is the stability of its orbit. Gliese 667c has a relatively circular orbit, which means it is unlikely to experience extreme temperature fluctuations. An orbit that is too eccentric could lead to a highly unstable climate, with the planet alternating between freezing cold and scorching heat. The stable circular orbit of Gliese 667 suggests that it may have more consistent and temperate conditions, ideal for life. Orbital stability. The orbital stability of Gliese CNCC is another critical factor in its potential to support life. As mentioned earlier, this planet orbits a red dwarf star, Gliese 607c, which is part of a trinary system. The stability of the planet's orbit is key to its long-term habitability, and in the case of Gliese 667c, its orbit is relatively stable. It is located within the habitable zone of its star, meaning that it receives enough energy to sustain liquid water, but not so much that it would cause the planet to overheat. The stability of the planet's orbit is also enhanced by the fact that it is in a tidally locked orbit with its parent star. This means that one side of the planet always faces the star, while the other side is perpetually in darkness. This could create extreme temperature differences between the day side and the night side of the planet. However, studies have suggested that atmospheric circulation and ocean currents could mitigate these extremes and create more balanced climate conditions, especially if the planet has an Earth-like atmosphere to distribute heat evenly. Moreover, the fact that Gliese 667 has a relatively close orbit around its star means that it is less likely to experience the disruptive effects of gravitational interactions from nearby planets or stars. Its stable orbit makes it more likely that the planet's environment has remained relatively unchanged over millions of years. providing a longer time frame for life to evolve. Conditions for life. So, does Gliese 667 have the right conditions for life? The short answer is that it very well might. Let's review the conditions that could make this planet habitable. 1. Water. The most crucial ingredient for life is liquid water, and Gliese 667 cc's location in the habitable zone of its star suggests that it could have the right temperatures for liquid water to exist. While we cannot yet confirm the presence of water, its position makes it a prime candidate for future observations to detect water vapor or oceans on its surface. 2. Atmosphere. The planet's likely rocky composition suggests that it could have an atmosphere capable of maintaining liquid water and regulating the planet's climate. If Gliese 667c has a stable atmosphere, it could potentially support a wide range of biological processes. The atmosphere would also provide protection from harmful cosmic radiation and allow for the formation of clouds and weather patterns, contributing to the overall habitability of the planet. 3. Gravity. At 1.5 times the mass of Earth, Gliese 667c likely has stronger gravity than our planet. While this could create some challenges for potential life forms, it also means that the planet is unlikely to suffer from atmospheric escape due to a weak gravitational field. This is an important factor in the long-term stability of the planet's atmosphere and its potential to support life. Conclusion: a promising candidate for life. In summary, Gliese 667 is one of the most promising exoplanets discovered to date in terms of its potential for life. With its Earth-like size, its position in the habitable zone, its orbital stability, and its potential for a temperate climate, this planet offers a remarkable opportunity for future exploration. Though there is still much we do not know about Gliese 667c, its characteristics suggest that it could be a world capable of sustaining life. Future studies and observations may help answer critical questions about its atmosphere, surface conditions, and the presence of water, providing us with even more evidence of the vast potential for life beyond Earth. As we continue our search for Earth-like planets, Gliese 667c remains a key candidate in our quest to find life on other worlds. It may be one of the most promising destinations for future interstellar exploration. Don't miss the next step in our exploration. If you're as fascinated by these distant worlds as we are, make sure to subscribe and stay updated on the latest discoveries and missions. The search for life beyond Earth is just beginning, and we're on the cusp of something truly revolutionary. Join us in exploring the infinite possibilities that lie beyond our home planet. Together, we'll continue to push the boundaries of what we know and reach for the stars. Thank you for joining us on this journey across the stars. Don't forget to hit that like button, subscribe, and ring the bell for more amazing insights into our ongoing search for life in the universe. The future is waiting, and we'll be there to explore it with you every step of the way.